Okay, now what do you mean by marginal utility? Okay, so suppose that an individual ranks goods by a utility function of the form, say u equals to, u depends upon x1 through xn, okay, where x1 through xn are the amounts of each of the n goods consumed. Okay, well, the marginal utility of x1 is mu x1, which is equal to del u by del x1. The reason we are using a partial derivative is that we are trying to find out how would the utility changes in case if the consumption of x1 changes while the consumption of all other goods being kept constant. Obviously, the value of marginal utility depends on the point at which the partial derivative is to be evaluated. Okay. Now, writing the total differential of this utility function, what is it that you will get? You have the utility function u is equal to u x1 x2 through xn. So du is equal to del u by del x1 into dx1 plus del u by del x2 into dx2 and plus so on to del u by del xn into dxn. Well, you know one thing, that del u by del x1 is mu x1, del u by del x2 is mu x2, and so on and so forth to del u by del xn is equal to mu xn. Now, substituting this into the earlier expression, what is it that you get is mu x1 dx1 plus mu x2 dx2 and so on and so forth to mu xn dxn. Okay, so this is the total differential of the utility. So what is it that this total differential is telling us? It is telling us that the extra utility obtainable from slightly more x1 through xn, okay, is simply the sum of the additional utility provided by each of these increments. Okay, so what is it that you get is that the extra utility, which is du, which is obtainable from slightly more x1 through xn, okay, is simply the sum of the additional utilities, provided by each of these increments. Okay.